Hello, my name is Steph, and today I'll talk about the comparison of Canada with the US in terms of emerging energy demands. So, specifically, the greenhouse gas reductions, electricity demands, and strategies used to balance reliability, cost, and decarbonization. So, the central challenge of this would be achieving net zero goals while balancing the growing electricity demand. The comparative overview of the USA, and this is for the years between 2020 to 2024. And between these years, total emissions increased by 4%, with the largest emitting sector being the transportation sector, closely followed by electric power. There was a decrease in emissions in the residential, industrial, and electric power sectors, 5%, 6%, and 0.6% and 1.6% respectively, and an increase in emissions in the transportation sector by 13%. In Canada, there was a 1.7 increase of emissions between the years 2020 to 2023. And between these years, there was actually a large increase in emissions, peaking at 700 megatons in 1 year before dropping to the current value of 694 megatons. The base year for Canada's greenhouse gas emissions reduction target is 2005, and Canada has reduced emissions by 8.5% since then. So overall, there has been a decrease in emissions. The oil and gas sector and the transportation sector are the largest greenhouse gas emitters, accounting for 30% and 23% of total emissions, respectively. Growth in emissions in the transportation sector are driven by increases from freight heavy-duty trucks and passenger light trucks. So both Canada and the US are experiencing an increase in energy demand driven by similar factors. And these can include data centers, the adoption of EVs or electric vehicles, and extreme weather conditions influenced by climate change. In the USA, the implementation of the Inflation Reduction Act, or the IRA, initially spurred investment in electric vehicles, heat pumps, and electrified buildings, but changes under the One Big Beautiful Bill has delayed many of these incentives. As a result, development of renewables is expected to slow even as electricity demand continues to rise. So the key challenges facing the power grid, which was built decades ago and wasn't designed for these modern demands, include an aging infrastructure, so a lack of new transmission lines, and aging existing infrastructure, which increases the risk of outages and decreases reliability, as well as the integration of renewable energy generation, which can create supply challenges during peak demand, as many sources such as wind and solar depend on weather conditions. In Canada, according to the IESO, electricity demand in Ontario specifically is projected to grow by 75% by 2050, mainly attributed to the industrial sector, so including the EV supply chain, manufacturing, and data centers, as well as an increasing population and focus on electrification. According to the CER, higher electricity consumption can make it difficult for grid operators to reliably provide sufficient power during peak periods. To meet increased demand while keeping costs and emissions from electricity generation low, additional supply of clean energy sources is widely expected across energy forecasts. Canada's grid, especially the bulk power system, or BPS, requires improvement and newer infrastructure in order to ensure reliability. The current grid is impacted by over 90 regulations across different statutes at the federal level, and similar hurdles exist at the provincial level. The approval of processes for projects are long and complex and can lead to missed opportunities and delayed project implementation. Strategies and innovations in the US include the US Clean Energy Innovation Strategy, which employs a threefold technology action plan to achieve net zero emissions. Number one in the plan would be to invest in R&D for game-changing innovations, The strategy emphasizes R&D of a broad portfolio of breakthrough technologies, including DOE's energy earthshots, which target cost and performance goals in long-duration energy storage, carbon removal, clean hydrogen, and more. The second strategy would be demonstration and early deployment, where demonstration projects increase market confidence and lay the infrastructure foundation for widespread technology adaptation. This also includes federal funding. Number three would be the implementation of regulations and financial incentives to accelerate deployment of available technologies. This strategy promotes the use of regulations and financial incentives to accelerate manufacturing and adoption of commercially available clean technologies. In Canada, the carbon management strategy for Canada highlights several strategies and technologies that aim to balance reliability, cost, and decarbonization. Number one would be CCUS technologies, which play a big part in Canada's strategy, as well as CDR or carbon dioxide removal approaches. These methods are costly and energy intensive, but benefit from Canada's abundant biomass, low carbon electricity, and suitable technology. Number two would be the R&D focus, where the government invests in accelerating innovation across the carbon management value chain, including next generation capture technologies aiming to increase efficiency and reduce energy use, modular systems, and commercial scale demonstrations. Number three would be policy and regulatory frameworks, including carbon pricing, refundable investment tax credits, and clean fuel regulations, which create market certainty, encouraging investment and deployment of cost-effective decarbonization technologies. Finally, there's the economic strategies, which include the Buy Clean initiative, which is a government procurement initiative that stimulates demand for low carbon products, supporting commercial viability and cost reduction. In conclusion, Canada faces significant challenges to decarbonization and requires acting early with smart policies to reduce overall costs and make achieving net zero easier. Electricity transformations will require significant capital investment, and strategic action through the implementation of technologies and policies are crucial. My recommendation is to grow the electricity system, as in update technologies such as implementing the use of smart devices to improve reliability, increase grid capacity by building more transmission lines, distribution lines, and substations, and increase generation capacity through the implementation of renewable energy systems, including distributed generation and energy storage. And here are my references.